Ever pondered on the end of everything? How will the universe, the colossal space we inhabit, meet its end? For as long as we've gazed up at the stars, we've been captivated by the mysteries they hold. We've wondered about their formation, their existence, and yes, even their ultimate demise. It's a fascination that's as old as humanity itself, this allure of endings and the unknown. The universe, vast and infinite as it seems, is no exception. Theories abound on how our universe might meet its inevitable end. These aren't mere speculations, mind you, but scientific hypotheses rooted in our understanding of cosmology, physics, and the very nature of reality itself. Consider, if you will, three principal theories. First, the heat death. Imagine a universe that keeps expanding, driven by the constant strength of dark energy. Matter dilutes, and over time this leads to a gradual fading of all energy differences. The universe, once vibrant and full of motion, cools and quiets down to a slow, inevitable halt. Then there's the big rip. What if dark energy doesn't just remain constant, but increases? In this scenario, empty space itself could rip apart all matter, tearing galaxies, stars, and even atoms into shreds. Lastly, we have the big crunch. Suppose dark energy decreases and matter wins the cosmic tug-of-war. The resulting gravitational pull could cause the universe to collapse into itself, crunching everything back into a singularity. Each theory presents a different endgame, a distinct cosmic curtain call. Yet, scientists generally lean towards the heat death scenario as the most likely one. After all, current observations suggest that our universe is not only expanding but doing so at an accelerated rate. So, what's your guess? Will we freeze, rip apart, or crunch up? Imagine a universe that's eternally expanding, diluting matter to the point where everything just stops. That's the essence of the heat death theory. It's a scenario that paints a picture of an ultimate end, a cosmic winter that turns the entire universe into a frozen wasteland. To understand this concept, let's first talk about dark energy. This mysterious force is believed to be the key player in the expansion of the universe. It's like a relentless engine, continuously pushing galaxies further apart from each other. Now, if this dark energy remains constant, the universe's expansion will also continue unabated. But what does that mean for us, for matter? Well, as the universe expands, matter gets diluted. Stars drift farther apart, galaxies become isolated islands in an ever-widening cosmic sea. Over unimaginable lengths of time, stars burn out, galaxies fade, and even black holes, those cosmic vacuum cleaners, will evaporate due to a phenomenon known as Hawking radiation. What's left is a universe with no stars, no galaxies, just a sparse sprinkling of particles drifting in the vast emptiness of space. The universe becomes a cold, dark, and desolate place. This is the heat death scenario, a universe devoid of heat and life. It's a theory that takes into account the laws of thermodynamics, particularly the second law, which states that the total entropy or disorder of an isolated system can only increase over time. In the case of our universe, it means that it is slowly but surely heading towards a state of maximum entropy. The heat death scenario is a gradual process, happening over trillions upon trillions of years. It's a slow march towards oblivion, where the universe, as we know it, fades into a shadow of its former self. It's a chilling thought, isn't it? It's a chilly thought, isn't it? A universe where everything just fades away. What if the universe doesn't just fade away, but rather gets ripped apart? Picture this. The universe as we know it, not gently drifting into oblivion, but being violently shredded at its seams. This is the essence of the second theory of the universe's possible end, the Big Rip. The Big Rip is a hypothetical cosmological model based on the premise that the strength of dark energy, the mysterious force driving the expansion of the universe, could increase over time. Now, what does it mean for us and our universe? Well, let's delve into the cosmic chaos that this scenario would entail. Imagine the universe as a loaf of bread rising in the oven. The dough expands, the bread grows. The yeast in this analogy is dark energy, fueling the expansion. But what if the yeast becomes supercharged, causing the dough to not only rise but explode, tearing the loaf apart? That's the Big Rip for you. In this scenario, the increasing dark energy would overpower gravity, the force that holds galaxies, stars, and planets together. The dark energy would become so dominant that it would tear apart the very fabric of space itself. Initially, galaxies would be ripped apart, followed by solar systems, then stars and planets, and ultimately even atoms would disintegrate. The universe, in its final moments, would be a cosmic soup of individual particles, flung apart by the relentless force of dark energy. Every particle would be isolated, drifting in a vast empty space, a far cry from the organized complexity of galaxies and stars we see today. However, before we get too caught up in this apocalyptic vision, it's worth noting that this theory, while fascinating, is still very much speculative. The nature of dark energy remains one of the greatest mysteries in cosmology, and its future behavior is still uncertain. It's an explosive theory, but it's not the only one. So buckle up as we continue our cosmic journey exploring the possible ends of our universe. Scene script. Or perhaps everything we know will just collapse into itself. Imagine that the universe's expansion slows down, halts, and then reverses. This is the idea behind the Big Crunch theory, the third principal theory predicting the end of the universe. The Big Crunch suggests a scenario where the universe's expansion isn't eternal. Instead, it postulates that at some point the gravitational pull of matter will overcome the force of dark energy. Now, what does this mean? Well, in essence, it suggests that the strength of dark energy, which currently propels the universe's expansion, will decrease over time. As the dark energy weakens, the gravitational forces of matter, the stuff that makes up galaxies, stars, and even us, start to take over. This shift in cosmic power balance leads to a gradual slowing down of the universe's expansion. But the story doesn't end here. Once the expansion slows down enough, the universe will stop expanding altogether. But the gravitational forces don't just stop. They keep pulling. This pull becomes so strong that the universe starts to contract, shrinking in size, collapsing into itself. The galaxies, stars, and everything else that we know start to move closer together, eventually merging into one single ultra-dense point. This is the Big Crunch, a reversal of the Big Bang. It's not an explosion of creation, but rather an implosion of destruction. This scenario paints a very different picture of the universe's end compared to the heat death or the Big Rip. Instead of an eternally expanding cold and dark universe, or a universe torn apart by its own expansion, we have a universe that ends with a bang, not a whimper. However, it's important to remember that these are just theories. They are based on our current understanding of the universe and its components, which is constantly evolving. And while the Big Crunch might sound dramatic, it's currently considered the least likely scenario by the majority of scientists. It's like a giant cosmic implosion. So, what do the experts think will happen? Well, most scientists lean toward the heat death scenario as the most probable fate of our universe. But why is this theory favored over the Big Rip or the Big Crunch? It all boils down to the observed behavior of dark energy, this mysterious force that's causing the universe to expand at an accelerating rate. If the strength of dark energy remains constant, as it appears to be, the universe will continue to inflate indefinitely. As it does, matter becomes more and more diluted until galaxies, stars, and even atoms are stretched so far apart that they can no longer interact. The universe would effectively cool down, reaching a state of maximum entropy or disorder. In this scenario, we wouldn't end with a bang or a crunch, but a slow, cold fade into nothingness. So it seems we might all just freeze in the end. But before we get too gloomy, let's remember the greatness of humanity. There's a fascinating concept out there known as the Human Era Calendar, a creation of Kurzgesagt. This calendar does something quite unique. It marks year zero, not with the birth of Christ or the beginning of any other religious or political era, but approximately 12,000 years ago. Why, you might ask? Because that's when we, as humans, began to truly work together. It was the dawn of agriculture, the start of human society as we know it. We began to build, to create, to innovate. We started to shape the world around us, and in doing so, we shaped ourselves. The Human Era Calendar reminds us of this collective achievement, of the potential greatness of humanity. So, despite the universe's eventual end, remember that humanity has achieved and can continue to achieve great things.